I guess today is a new day, and yeah, we have to continue with our Godot tutorials. So I think before the animated our character and stuff like that. So now we have to get into the programming side from the way I see it, because what we've been doing mainly is just exploring Godot, and we've done some animations to our player character. So now we have to begin. Mm-hmm. Yeah. First, let me get my hand ready. Ah. So let's open Godot. So as you can see, this is our player character enjoying the ride over here. Yeah, you see, running like a good little kid it is, just running. So I'm just put this on it, and we are going to create a script. So in order for us to start the programming, the first thing that you have to do is create a script. You don't need to enter into the script window here. You just go over here, the create script button is there. You click on it. Then usually the script will have its properties borrowed from the node that you are taking the script from. So the language that we are using, of course, is GD script. We're not using native script or Visual script. It's GD script. Then the inherit means that what are the properties of the script? Where are we taking the properties of the script from? So usually we take the properties of the script from the type of node that our node is. So our node is an area 2D node, or the type of scene that our scene is. Then the template, of course, our template will be the default one. Then built-in script, of course, we turn that off. So the path will be the same path for the player character. So the right script is valid. We'll create new script file. So create. So here you can see we have extends area to the func ready. So I'll explain these two. So these two extends area 2D is basically saying that we are going to be working in an area 2D Then func ready, the func ready is called when this node enters the scene, or basically it's the function ready is played when our player enters the scene, or when the game first starts. It's not necessarily when the game first starts. When like, let's say we have another scene there, and we introduce the player into the scene, then that's when this ready will activate. So whenever this comes on, whenever we do something with this will automatically come on. Then also over here you can see called every frame delta is the last time. So you can see that this is in gray because they are comments. They are comments. That's why they are in gray. But if you remove them from the comments, it reveals a normal function like this. So func process delta pass. So this function called process is called for every frame, and the delta is the time that is in between each frame. So it could be in milliseconds or in seconds. So every time that a frame passes by, we get this. So right now you can see we've gotten a warning here. So the warning comes from the fact that the function delta, the function parameter delta, is not being used. That's why we got a warning. So you can ignore that. Unless for now you're not really going to use it that much. So I'll put it back. Right. When we use it again, I remove it. So this is for every single frame that passes by, as long when this is in the main screen, or when we are running this node. Whenever we are running this node, after every single frame, whatever is in process will run. And here this is when the first frame is created. This is what will run. So this for the first frame, and this for every single frame after it. So this function runs only once, and this function will run continuously till we exit the frame, till we exit the scene, or to the node is deleted. So now I'm going to copy what I write here. So we are going to need three variables. You're going to need a variable for speed and a variable for velocity, and then you're going to create a variable called screen size. So the reason why we need a variable for speed is because we want to control our character's movement. And when our character is moving, we want to control how fast to move. So we will create a variable for speed. Then velocity. Velocity is basically, speed and direction. We will have a variable for velocity, which will be a vector. So that basically by compressing the keys that we use to control the character, it will control the character's velocity or direction. Then the screen size variable is just for to prevent certain things from happening. So let's start. So var speed, var velocity, var screen size. Okay, so you see some of these things we want to tinker them from outside the script. We want to tinker them without having to necessarily go into the script. So what I'll do here is I'll just type export into brackets and var speed. So what I've done is that I've exported the speed variable into the inspector. So if I save this and I go to player, there'll be a script variable there in speed. Now the reason why I had to indicate that this is an integer is because in Godot is variables are like Java variables or Python variables. They don't have a specific data type. So if you export it, you have to indicate the type of values be entering inside it in advance. Or else you can enter an alphabet inside it also. But right now we are just working with integers, so our speed will be an integer. So you can set the speed to any speed I like. Usually it should be around 200 or 300. I'll put it at 350 like that. Then we've exported the end. So now we want to indicate that our velocity is a vector. So vector 2. Then we want to indicate our screen size too is a vector. Vector 2. So this will have the x and the y over here. So we already know what our screen size parameters are: 480 and 720. So basically this is the screen size as a vector, these two. So as you can see, we've done this. So now we're going to create a simple script that will help us move the player. So in the script, what you're going to do that the script has to do three things. First thing, you have to check for input. So you have to check what button the person is pressing. Then the second thing that you have to do is that we have to move inside a given direction. So when the person presses the button, then we tell the computer that the person has to press the button. So we have to move inside that direction. Then after that, you have to play the appropriate animation, which is the animation that is run. So whenever we press a button, the character will move on the screen and we play animation run. Now, the reason why I have to play the animation run is because if you don't play the animation, it will just look like a picture is moving on the screen. It's not look realistic enough. In fact, most of the time, whenever you are playing games or so, anytime the character moves across the screen, it's not necessary. You are moving the character at the same time playing an animation. If you don't do that, the character will be stationary on the screen and it won't have that sense of realism attached to it. So what we do is that when the person presses a button, it moves the character, it translates the character across the screen, and it plays an animation. So first we have to check the inputs. So the input actions, if you go to the project settings and go to the input map, these are the input actions. So you have different input actions. You have one for accept. So accept can be enter or space. Then for select space, cancel is escape, focus next. So as you can see already, our some of our inputs have been defined over here. So up, down, left, right. So you can add your own inputs if you want to. That one you can decide My legs are free. My legs are free. I'm taking a short break, man. Taking a short break. Seems like I didn't watch over the time and my recording ended. So if you want to add an input, you just press this button. Like for example, if I wanted to add an input, I'll just press this button, then key. Then to ask me to press a key, let's say bin. Then I'll confirm. Okay, then to appear here. Like that. But I don't want this, so I'll delete it. So as you can see, there are even this in Xbox and Nintendo parts over here. Xbox, Y, B, and the rest. So you can put in your own keys. So the keys I'll be looking out for is left, right, up, down. So the assignment that I'll give is that you also have to program them that W is left, W is up, S is down, A is left, D is right, like most games. So for now, yeah, they've done the left button, right button, up the button, down button, which are the buttons on our pad over here. Over here. Yeah, like that. So let me close this. So we are back. So there's a certain function called input is action pressed. So what it does is it checks whether we've pressed a certain key or not, and if we press the key, to return the value true. If not press the key, to return the value false. So we are going to create a new function. Let me clear this. We don't need this, and let me remove this. So you are going to create a new function called function get input. So function get input. So first we are going to call in our velocity. So you already know that our velocity is equal to vector 2, like that. So I'm sorry, made a small mistake. If you don't bring the brackets, to give you an error. So we are going to check whether an input has been pressed for each of them. So if input dot is action pressed, UI left velocity dot x minus equals 1. So as you can see, I don't want to bring up my whiteboard right now and show you, but remember how the axes go, that the downwards is y and the right is x. So downwards is positive y and right is x. So what we've done is that if the input dot is action pressed is left, the velocity of the x will become -1. So the more we press the left button, the more the velocity becomes negative in the x-axis. Remember that right, as you can see my mouse, right is negative, right is positive, left is negative. That's on the x-axis. So what we've done, we've called the x part to the velocity. That's, you see over here, if you're working with screen size, if you provide screen size of the x, you'll call 480. So what's done is anytime the action pressed is left, the velocity on the x will decrease by 1. So I'm going to copy this like that. So the next action that we're going to do is UI right, and for that the velocity will be positive, because in the right, that is over here on our axis, is positive. Then we are going to do for y. So for y, negative is up and positive is down. So velocity dot y. Like that. So what is done that anytime you press a button, we ascribe a velocity to the velocity function. So now we are going to add a final if statement. So what are the reason why I've made them all if statements and not I've not added any switch statements or something. There's not really a switch statement, but like there's something similar to switch on it. The reason why is because if you press two buttons at the same time, one them to move diagonally, and if you use something like a switch statement, they will not move diagonally. They may move diagonally, but you see, you are in a sense you are beginners here. So I just want to use an if statement. So now we are going to do a final check. So if the velocity dot length is greater than 0. So yeah, if you've done vectors, you know what I'll be talking about here. If the velocity length is greater than 0, I'm going to multiply our velocities scalar, or our velocities, if you normalize the velocity, you get a scalar. So our velocity dot normalized times speed, like that. So over here, what we've done is that if the velocity length is greater than 0, that means that if our velocity gets a very long length, that's the length is, that formula that you use to find the length of vectors. That if it's greater than 0, what we do is that we take the velocity, then we normalize it, then multiply by speed. So normalize it means that you make the velocity a unit vector. So we'll make the velocity that we get here, it's become a unit vector. So if the velocity is 48720, it may not be a unit vector, but we make it to a unit vector. That means we make the length 1, then multiply by speed, because what we need is the speed. So we always want the speed to be constant, and the speed in a sense is the length. So our length always has to be 350. So if our length is greater than 0, we multiply the normalized velocity by speed. So a normalized vector will have a unit length of 1. And when multiplied by the speed, that means that the velocity will now have a unit length of 350. So no matter what, the scalar version of the velocity, which is the speed, will always be 350. That's the meaning of this. So now, one problem that we may have is that with this, we've given a character that you're given, some form of, you're given the controls here. So now we'll need to mixing up my words. We're given the controls here. So now we'll need to go over here and I'll enable the character to move around in the screen. So that means that I only need this. I'm going to remove this. I'm going to remove this. You will not need this. So for every frame of delta, we are going to get our input. We are going to call the function that we made get input. So that means that anytime that every frame runs, we are going to check whether we have input or not. So if we have input, then that means that the velocity that we've done over here will have something inside it. So we want to call out that velocity and make it that the character's position will move based on that velocity. So that means that the position over here that we have will be equal to the velocity times delta. So the velocity times delta. So the reason why I've added delta here is basically velocity will be meters per second and delta will be the second. And also remember that delta is for every frame. So we'll need the speed of the frame here to keep the character in check, because if there's no frame speed here, the character may go fast. So right now we've tied our this in. We've tied our speed to our frames. Then my legs are free. My legs are free. I'm taking a short break, man. Taking a short break. Like keeps on getting running out. So I think this will be the last part of the video. This will be rather short. So position plus equals to velocity times delta. We've gotten that down. So as I said in the previous part of the video, the amount of frames will be tied down to this part like that. Okay, so now I'm going to show something. Let's go back to the 2D, save, and let's run. I'm going to run this project. So running is a way of testing it. So every time you run the project, it will serve as some form of test. Okay, I think I've already programmed the up and down. Well, okay, let me try to run this again to see whether I've made any errors. Okay, I think, yeah, I've seen the problem. Down, yeah, small mistake. Let's run it again. So I'm going to introduce you a side problem. We've done our controls. You can see the character is moving. Right now, I've not given any animation, so our character is just doing this. So there's a problem. The problem is that our character is moving off screen. We want it to stay within the frames of the screen. We don't want it to move beyond this region. We want it to stay on the frames of the screen. Right now, it can pass through anywhere. And we will not want a game where a character can go out of the screen and to be difficult to bring it back. So we're going to use something called clamp. We are going to our clamp our values. So what I mean by clamp is that a clamp puts our values in a certain range. Like it's like it limits the amount of values that a variable can have. So we are going to put all this in clamp. So position dot x equal to clamp. So the first thing I have to do is the value that we are clamping. So we are clamping position dot x. Then the value that we start from, that's the minimum, 0. Then we're going to end at screen size dot x. So that means that we'll end at where the screen size ends. So we end at where our screen ends at. So our screen will end at 480. The length 480. So we'll stop at 480. So let's do the same thing. Position dot y is equal to clamp clamp position dot y comma 0 comma screen size dot y. So let's save this, and if you run the Godot, we get this. So now our character cannot move off screen. It can only move up to the boundaries of the screen like that. So later on, you add proper animations because our character when it moves like this, it doesn't turn, and it keeps on playing the same animation. So later on, we'll change the animations depending on the movement. So I guess